So just want to welcome you all. Thank you for joining us for today's PL SQL office hours session. Today we're going to be looking at calling functions, PL SQL functions, when you're using SQL statements. We're going to be discussing various ins and outs of that, the performance impact and so on. As always, feel free to put any questions you have in chat. Me and Stephen will be keeping an eye on it as we go along. So I'll be leading this. Stephen, you want to say a quick hello?
Yes, well, I'm glad to have Chris take the lead on this one. He's got a lot of interesting insights and more experience with some of the performance aspects of calling PL SQL functions in SQL than I do, but I'll certainly be poking in with my own ideas along the way. Take it away, Chris. Thank you.
Okay, thank you, Stephen. All right then, so I will jump back over to the slides, and we'll kind of get started properly. So what we're going to be looking at is kind of common reasons that you might want to use functions in SQL. So quite often you store names in your database, customer names and so on, and this can create some problems because people always type their names in different types of case. So some people put it in cap, some people a little bit lowercase and init cap and so on. And quite often you want to have a standardized routine for formatting the name so everything appears in the same way. However, this is a bit more tricky to do than it first appears. Why? Well, it's all thanks to our colleague Connor, who has a lovely surname McDonald, which has the little capital D part way through. So you can't do something straightforward just like init cap. And so you need to look at the name, see if it starts with Mac or Mac, and do some formatting as a result, which gives something that looks a little bit like this, okay? So this is not really the purpose of the talk today. I'm not really going to explain what's going on here, other than just say, like, this is really messy, right? There's a lot of things going on here, and this is just one column of presumably a much larger SQL statement. So this isn't great. So people look at this, and someone almost inevitably says, well, can't we make this easier? Can't we simplify it? Can we make it reusable? Because so far, that's formatting's localized to one SQL statement. Normally, if we do this kind of thing, we'll want to be able to format names as a standard way across the application. So you don't want to have to copy paste that horrible case statement everywhere that you're going to have to display somebody's names. So somebody says, let's make it reusable. Let's come up with a way of doing this. And you go, okay, well, how do we make things reusable? Well, we create a function. So you take all that code and you stick it in a nice function called format name or whatever it is, and just pass the parameters in. Nice and easy. So our SQL statement looks a lot simpler now, and we can reuse this wherever we want. So any screen it needs to appear on. And of course, if we have other formatting requirements, maybe there's extra formatting we need for things like the Irish names with the O'Farrell, O'Connor, that kind of thing. Maybe we want extra rules for those. We've got a standardized place where we can manage the whole thing. So this is great, and it's looking good until someone kind of pipes up. There's probably the first person who was talking about, making things reusable as well. They kind of go, well, hang on. Isn't there going to be some performance overhead to this, right? Isn't there going to be some impact to calling SQL statement, this PL SQL function in all our SQL statements? And okay, you sit down and go, all right, well, we better test this. Let's look and see how it actually impacts what's really going on. So you load up the table, you have, a million rows worth of people, and you run some tests, and it comes out a bit like this. So we got our straightforward case statement in the select query, and it's nice and quick, takes just under a second to process and everything. PL SQL function, on the other hand, slows things down considerably, so up to around 4.5 seconds, so about 4.5 times slower. So it's like, okay, this is potentially a lot of overhead we've got here. So we're slowing things down quite a bit by calling this PL SQL function. So the key question is, okay, so why? What's going on here? Well, this comes down to the way the database processes the queries. So the SQL engine and the PL SQL engine are actually two separate things. So every time it needs to pass from the SQL engine to the PL SQL engine, we have a context switch. So we get the rows out of the people table, and then we pass the information for each row to the format name, and then pass it back. Then we do it for the next row, pass it back, and the next row and pass it back, and so on and so forth. So each row that we return in the query, we're going to have to pass this backwards and forwards between the SQL and the PL SQL engine. And this is introducing quite a performance hit. This is actually quite bottleneck, what's really kind of slowing us down a bit. So someone again pipes up, well, can't you just make it faster, right? Surely there must be some magic switch you can use to improve the performance of these function calls within your SQL statements. What can we do, or how can we go about this? Okay, so there are quite a number of techniques you can use. So we're just going to walk through all of them briefly, just kind of introduce the concepts and discuss why they work. So just briefly, I see Niels, you're saying, is it possible to reschedule the next office hour? I'll catch up with you about that later.
Yeah, I'm responding right now, Chris. Thanks.
Yeah, okay. Okay, so how can we make it faster? Let's say there's lots of techniques, and we'll start with one that doesn't involve changing the function at all. It's actually changing the SQL statement, and it's doing something like this. So what we've got is we've got a scalar subquery. We are wrapping the function call within another select. And it's like, well, hang on, how does this help? How does this do anything different here? We're just calling an extra SQL function, surely that SQL statement, surely that will slow things down a bit. Well, Oracle Database has this really neat feature called scalar subquery caching. What that means is for each unique set of values, it can call this subquery just once. So if we've got people with the same name, and we run this function the subquery more than once, well, it can save the results and reuse those. So it doesn't actually have to call the function at all. And in particular, we no longer even need to do the context switch from SQL to PL SQL. So we're saving ourselves the overhead of executing the function, but actually doing the context switch as well. And this can be quite a big performance benefit, as we'll see. So it looks kind of funky, looks kind of weird, but this is a little trick which can give you some performance benefit, just wrapping your function calls in a scalar subquery. Okay, so that's first technique, and that just involves changing the SQL statement. And yeah, maybe it'll give us some performance benefit, but this is kind of a pain to do, potentially. If we're calling this function in tens, hundreds of SQL statements, it's a bit of a faff to go through every single one of them and do this. Maybe you could pick off a few which are really slow, but it'd be nice to have something which is a bit more general, right? Something which applies every time you call that PL SQL function, rather than just your individual SQL statement. So there are numerous techniques we can use on the function itself. One of these is to add the deterministic option, the deterministic clause, when you're defining the function. So what we're saying here is, given some input, we always expect the same output. So if we pass in Chris Saxon, we always expect the formatted Saxon, Chris. If we pass in Stephen Feuerstein, we expect it that way. Pass in Connor McDonald, we expect McDonald to be formatted correctly. So every time we pass in the same values, we are going to get the same result. So it is deterministic. So we're telling the database that. We're going to say to the database, mark this as deterministic, and then it's up to you. You can find if there's any optimizations that you can use to find and do this more efficiently. Save the results like we had with scalar subquery caching and so on. So when we've got a deterministic function, we're giving more information to the database. We're telling it, we know that the results given this function, given these inputs, we're always going to get the same outputs. So declare that, tell the database that. And this can help give a more general performance benefit for everyone who calls this function. Okay, so that's kind of first option we'll look at with calling the function. Another thing we could do is kind of pre-compute the result. So if we're going to have the same values passed in multiple times, rather than recalculate every time, it'd be nice to kind of like officially save it. And in 11G, we introduced something called the function result cache, which allowed you to do this. So there's a special area of memory which we reserve for this. So you call the function. First time you do it, it says, is these parameters in there? Based on these parameters, have we got result in the function result cache? If we have, get them out. If not, then we'll populate it in. So this is kind of a self-managing thing, and it will, based on the values we pass in, return the result from the cache. So this can avoid executing the function at all. Okay, so we will need to do it at least once for each unique set of values. We might have to run it multiple times, it's part of memory, so there's limited space available, but potentially this could give us more performance benefit. Okay, so we've looked at marking it deterministic, we've looked at saving the results. Another thing we could do is, let's say we know we're only ever going to call this function from SQL. So we're only going to use it in queries. We're not going to use it within other PL SQL processing that we've got, for example. What we can do is mark this as a user-defined function, a UDF. So there's this pragma which came in 12C, which is basically telling the database, well, this is something that we're only going to use in SQL. And what this allows the database to do is lessen the overhead of that context switch. So this is a feature which has brought about a lot of controversy. You might see why. We'll see a little bit why later on. But the idea behind it is we're saying to the database, again, we're declaring something we know which the database can't know. We only want to use this function within a SQL statement, so use that information and try and optimize it as appropriately. Okay, so there's various techniques we can use to improve the function itself. However, there's another technique, and one that I like personally is my favorite, and that is something we introduced in Lemon G, is called a virtual column. So here we define a column which is the result of a function. So here we literally paste in that SQL that case statement, or we could call the function itself. We could put, formatted name, the PL SQL function we want. Either way, we're now putting it part of the table definition. And the reason I kind of really like this is when somebody's querying the table, a new developer joins your team or whatever, they query the table, they will see that column is there, and they're not then going to start hunting around and kind of going, oh, I need to write my own, formatted name. I'm sure you've all seen it. Big teams or big applications, you write a nice set of utilities, and for whatever reason, new people are not made fully aware of this and go off and start writing their own utilities which duplicate the functionality. By making a virtual column is part of the table, and people are much less likely to miss it. It's just right there, staring them in the face whenever they query the table. So I really like this. Now, as I said, you can paste the case statement in directly, or you can call the PL SQL function yourself. It's kind of up to you. Personally, it depends on how else you want to use this. Okay, so that's kind of a recap of the options. Anything you want to add to that before we move on to the performance tests, Stephen?
No, I think we're good. Let's go.
Okay, cool.
Oh, I'm sorry, one thing. Judith mentioned in the chat that the place to really be wary about calling these functions is in the where clause, and I think you're actually going to be taking a look at that coming up.
Yeah, we'll discuss functions in the where clause a little bit later. We're just going to talk more generally about them for now. Okay, but that is a great point, Edith. Okay, so we've got these various techniques. The obvious question is, like, well, which should you use? Which is going to be better? Which is going to come out, make the most savings to our SQL statements here? So again, I kind of repeated that test. I had 1 million rows, and I ran each of these different functions and see how long it took to actually execute them. And we got something that looked a little bit like this. So as you can see, we got the times here, so the bigger graphs means it's taking longer. And we got our plain SQL, which was just under a second. Now the scalar subquery, interestingly, actually came out faster than just pasting the case statement into the SQL itself. You might go, well, okay, why is that? Well, within that case statement, we had to do a whole bunch of stuff. We called a regular expression, we did some init cap, and so on. So we do have some duplicate names in there. There wasn't many, but there are some repeated names in there. And so in those cases, the database didn't need to re-execute the whole of that expression. It just computed it once and it was able to reuse that value from the scalar subquery and cache that. So actually, this gave some real performance benefits. Again, deterministic database was able to use the fact that it knows that given these inputs, I expect these outputs. So save that, reuse the results if possible. So again, that gave some good performance benefits. Now at this point, some of you might be interested. It's like, well, hang on, we had this result cache. We were using this to save the results and then not have to execute the function. So why is this so slow? You know, it's the slowest option other than just straight PL SQL, you know, the vanilla option here. So what's going on here? Well, every time we call the function, first thing it needs to do is check if that result already exists in the cache. And if it doesn't, it has to execute the function itself. There is some overhead to doing this. So the very first time we call it for each new name, then we're going to have to do some extra work. And the thing with names is they're not unique, but they're fairly close. You know, there are a handful of Chris Saxons in the world. You know, maybe if you've got a popular name like Jeff Smith, there might be hundreds of, maybe even thousands of people with the same name. But in general, there's relatively few rows that are going to have the same values here. So we're hitting that, getting that overhead of having to figure out whether it's in the cache, actually run it quite a lot. And in many ways, I made my data set probably a little bit forgiving here. You know, I repeated the names 100 or so times. So real data, real names, yeah, maybe you wouldn't even get as much benefit of this from the function result cache here. So that's something to be aware of. We've got pragma UDF, which gives nice benefit, nothing remarkable, or at least not compared to some of the other approaches. And our virtual column's pretty much the same as plain SQL, because really it is. I've just taken that case statement, stuck it in the virtual column. So really effectively, it is the same thing. Okay, so any questions or comments? Anything you want to say, Stephen, before we move on?
Yeah, just one thought. It's interesting to see, for example, the pragma UDF, which is this new feature in 12c, is not more impactful. And there have been a number of blog posts actually about how the UDF pragma works differently for different data types, even for the function inputs. So one point to make, this is really carrying in from what Bryn Llewellyn, the PL SQL product manager, has talked about, is that regardless of what you see in this chart and what the behavior is today, what you really want to probably want to do is take advantage of all the declarative aspects of the language whenever you can. So for example, if your function really is deterministic, mark it as deterministic, even if it's not going to have any impact on performance, because the chance of it helping is actually pretty small since the scope of caching is so small. Pragma UDF, if you know that your function is almost always going to be called from within a SQL statement, put the pragma on there, even if you decide you're going to use the scalar subquery right now, because in the future, we will get better, I'm certain of it, we'll get better at leveraging things like the pragma UDF, the deterministic keyword, whereas the scalar subquery approach might, for some reason, due to changes in the optimizer, be less advantageous to you. So just always try to use the built-in features, the declarative features, as much as you can. You're giving more information to the compiler and the optimizer to sort things out as we get better and better at our autonomous features.
Okay, that's great. Yes, thanks, Stephen. And I've got another example coming up, which showing that, you know, this is just one query, one data set. If you do it on, you may get different results if you run it on different data. So this, we were looking at formatting names. So let's look at another common thing that you might want to function for. That is calculating people's age, right? So you'll store their birth dates. You can't store their ages because then you have to have some crazy job in the background which goes around every day figuring out whether anyone's got a year older and incrementing their age. That's just a bonkers solution. This is the kind of thing you really want to be calculating on the fly. So we want to add some birth dates, the actual ages. So we need a function to do this. So basic principle here is we do something like this with finding the months between today and their birth date, divide by 12 to get the number of years. Okay, so hang on, I see a question from Joseph. So result cache performance might be better for functions that only take a small number of direct inputs. Yes, as Stephen says, the small number of distinct inputs will help in terms of how much memory is needed for the cache pool. So yes, small number of inputs is going to help with the result cache. Anything you wanted to add to that, Stephen? I see.
Yeah, that was the first part. So Joseph, I think you're right that if there are a small number of distinct values being passed into the function, then you're going to get more benefit out of the result cache because, first of all, you're going to be hitting those same values over and over again. and also because you're not going to need so much memory for lots of distinct values. But besides the number of values, what it really comes down to is how often your users are hitting the same values. You could have a lot of values. You could have a large result cache pool. But if you have a very large number of users constantly hitting those same large numbers of values over and over again, you still will see the benefit from the result cache. But one thing to watch out for with the result cache, and there are lots of blog posts about this as well, is that the startup time, filling up that cache, can be painful. And I believe that there are actually users who rely on the result cache who actually like pre-fill it. They have a process that actually loads it up, gets it ready, so that it's not happening on a hit-by-hit basis for the individual users.
Okay, that's great. Yeah, thanks, Stephen. So as he says, you've got to look at how many different values are, but how often you're going to call it. You know, if you've got, you know, even if we've got a million rows, let's say 10, 20 different values, but this is a SQL statement you run once a month, part of a batch job. Do you need the result cache? Well, you know, obviously it depends. So you've got to think and figure out your performance trade-offs, what's going to help here. So anyway, let's continue with the calculating the age. So I kind of repeated the process. I created one of these each different functions. I just did it in plain SQL, scalar subquery caching, deterministic keyword, and so on, and got the results that looked something a bit like this. So now there's a couple of interesting things going on here. First thing is we notice now that the pragma UDF is got a lot slower, and in this case is actually marginally slower than the straightforward PL SQL. So this is one of the reasons this has brought about some various controversies. People saying, yes, it does, it can, and it does improve performance in a lot of situations, but based on data types and so on. So here we're working with dates rather than straightforward strings. You may not see any gains. In fact, you may even see things marginally worse. So do check this one carefully if you're going to be looking at it. Ideally, as Stephen says, this is something we're telling the database. We're telling the database and the optimizer we're only going to use this in SQL, so optimize and figure out appropriately. But make sure you check this one. Notice other thing is the result cache is still taking a while, but the relative performance is better. So it's kind of a little over half of normal PL SQL compared to before, where it was a much larger proportion. And this is because there are far fewer distinct dates. Okay, you know, however many, we've got 7 billion people in the world now. There's a lot of different names out there, but there's still only a fixed number of different birth dates available for them. So still a large number, but it is a smaller number, you know, at least a couple of orders of magnitude smaller. So we are getting more benefit from the result cache here because we have those startup costs of initializing it for the new values. Well, we're not having to do that as often. We have fewer different values that we're passing into it, so we can get more benefit from not having to call it all. So result cache and pragma UDF, again, we're getting mixed results here. However, scalar subquery and deterministic, both of them come out really well. You know, scalar subquery in both cases was faster than our plain old SQL approach, and deterministic was only marginally slower. However, you see I've kind of put the winners in with a question mark here, and that particularly relates to the deterministic keyword. So you'll notice there's nothing in the virtual column bar here. You know, there is no time. And why is that? Well, we can't run it. If we try and add the virtual column in here, we get this lovely error, you know, or 540002. Problem is, it is non-deterministic. Each time we call it, someone's age could have changed. So each new day, someone will have got older if our data set's large enough. So it is a non-deterministic function. Given the same inputs, we're going to get different results on different days. And we don't allow this in virtual column definitions. So this is potentially a problem. Now, at this point, you might be tempted to kind of cheat and go, well, why don't we just kind of like declare it deterministic? Say, yeah, we know it's not deterministic, but let's work around this and just say, yeah, it's deterministic really. So we'll create our calculate age deterministic function with a deterministic keyword in, then we can add the column and we're all good, right? Yeah. Well, at this point, we are now lying to the database. You're saying, this is something that is deterministic when it clearly isn't. It's going to get different results based on the same input. So what problems can this cause? Well, quite serious ones potentially. In particular, if we create an index on this, so let's say we're going to find people who are a particular age. So we create our index, and we'll set the date to the start this year, and we only get one row that returns that result. So, you know, a million rows in the table, only one row matching our query, so we're going to use this index. What happens if we now advance the year on? So I love this little fixed date thing. What you can do is just say, set the database. This is now the date for the database. Makes it really useful if you ever need to do those time-based testing things. Something I wish I'd known about 6, 7 years ago when I was doing a lot of kind of price changing testing to analysis, you know, check would the price change at a particular time to the correct values, but potentially really useful if you ever need to do that kind of future dated tests. Anyway, bit of a side note there. So we've got this fixed date, and I'm now fast forwarding towards the end of the next year. So now if I query for looking for people who are aged 39, then we shouldn't get anything, right? Because my row, or the row for Chris Saxon, will have advanced a year. But what do we find? Well, the age, we still get the row. It's like, well, why is this? Well, the index stores the value for the row at the time of insert. And that said, the value was 39. So even though time has moved on, time has changed, then that index entry has not changed. There's been nothing to update it. So we've lied to Oracle. We've said something's deterministic that is not deterministic, and we've got a different result then. So we've lied, and we've got some incorrect results here. So deterministic option seemed like it gave big performance benefits, but only at the cost of potentially giving us the wrong results. So something to really watch for here.
And Chris, Judith comments, in fact, it is deterministic because when sys changes, that's a different argument value anyway.
Okay, so no, we are passing in, the only argument we pass in is the birth date. Okay, so sys itself is a non-deterministic function. It has no parameters, so if it was deterministic, every time we call sys, it would have to return the same value. But it clearly doesn't.
Good point.
So that's the point here. A couple of things. Our function itself, I guess if we go back up a couple of slides, actually, I don't think I showed this one particularly. We are only passing in the age, or the date of birth. We're not passing in sys to the function. So we only pass one parameter, which doesn't change. So this is a non-deterministic function. Okay, so, and remember itself, sys is non-deterministic. So this is something, you know, if the result changes without you changing the parameters, it is non-deterministic. Okay, and I don't know if you want to add anything to that, Stephen, or
just the rule of thumb should be don't lie to the compiler.
Yes.
You're bound to run into trouble.
Exactly. So obviously, deterministic can give good performance benefits, but only if it's really true. Only if you're actually doing something that really is deterministic. So any other questions or comments on that in the chat before we move on a bit?
Doesn't look like it.
No, it doesn't look like it. Okay.
Oh wait, here we go. So a virtual column is calculated and stored as we insert and update?
So great question. So no, the virtual column is always calculated at runtime. What you're storing is the function essentially on the table. You're not storing the result of the function. You're just storing, you know, calculate age or whatever it is. So at runtime, the database figures out what the result is. You don't store what it actually is. And you know, this kind of solves, there's a big debate. If some of you are familiar with third normal form, the idea is you shouldn't store any values which are calculated or based on any other columns which aren't the primary key of a table. And this causes a lot of confusional issues potentially when it comes to calculated values. So things like with order lines, you might have quantity and unit cost, and you want to say the total price for each line, which is just you multiply the two. Now, people are going to go, well, it's kind of an overhead, and it's a pain to have to write that function every single time that you want to query this row and you want to get that value back, particularly as it's something that's really common. Whereas pure third normal form, people say, no, it's calculated, don't store it, because eventually you'll get data corruption and you'll return the incorrect value. So virtual columns kind of offer an in-between approach. You're not storing the result, but you are storing the calculation, so at runtime you can get different values from it.
And Judith has a couple of other comments. If the virtual column is indexed, then it is calculated at DML time for the storage of the indexed value only. And Joseph asks, are there any plans to add support for materialized column, like a virtual column, whose value is calculated and stored with every insert and update?
Okay, so Judith, if the virtual column is indexed, then it is calculated at DML. I'm not sure. I'm not sure exactly what you're saying there, Judith. But so there's a couple of one thing to watch for on when it comes to this virtual columns. So it's only when you query it, it's calculated at runtime. When it's in an index, the only time the value in the index changes is if you insert the row or update the affected columns. Otherwise, the index doesn't change. Okay, so this is why we got this error where we're returning someone's row when someone who's 40 when actually they're 30. Someone asking for 39 and returning someone who's 40. So we're getting incorrect values. So in a way, the index is the materialized column, Joseph. That is actually storing the result you got at the time you inserted the row. I'm not aware of any functionality which will make this kind of part of the table definition. However, what you could do is create materialized views. So these are tables where you've pre-computed some results. For example, these could be function results like this. More typically, you'd use it for things like complex joins or aggregating lots of rows. So we want to get the summary, the total number of sales, or the total number of orders each day. We're going to have millions of orders a day. We don't want to scan all those. We just group up the results by day, store those in materialized view. So now we've only got a row per day, 300 odd per year. Okay, right, but it would be nice not to have to find an index to get the functionality. Yeah, I guess so. Like I say, I'm not aware of any plans to do that beyond what we offer in materialized view. I don't know if you've heard anything, Stephen, or
I have not, no. And if we heard it, we probably couldn't say it anyway without throwing up a safe harbor statement. So no, nothing I know about for 19, which is out, or 20C right now.
Yeah. It's worth saying, if there are features like this that you want to see, we have got our database ideas forum, the community ideas, which you can submit your own suggestions of things you would like to see in the database, and the community can vote for them. No guarantee that it will be implemented, but obviously things that have a lot of community support, easy for us to do, and fit with the direction we want to send the database, are some more chance of it being done. You already do have it through triggers. I guess, Judith, you're right. You could create a trigger which every insert update modifies the values explicitly. I guess, Joseph, you're looking for something a bit more inbuilt. Okay. Yeah, that's what I do. Okay, so you're looking for something other than the declarative feature. Yeah. You'll have to stay tuned for that one. All right, then. Okay.
That's definitely the right impulse. Push for declarative whenever possible. Absolutely.
Exactly. All right, then. So we'll move on a bit. If you're still typing away, don't worry about it. We'll pick up your question later. So let's move on. So far, we've been looking at kind of pure functions. We're taking some values and just doing some calculations on them. So formatting a name, calculating an age, and so on. What if actually we want to run some SQL within there? So we've got a SQL statement we're calling a PL/SQL function, which itself runs a SQL statement. So, for example, we put our get age function in here like this, and in there we look up the person, and we call this function within our SQL query. So what about this, and what are the things that we need to watch for here? Well, this first thing to think about here is, of course, we've kind of got double context switch. We're going from SQL to PL SQL and back to SQL again. So potentially we've got 2 overhead hits of that context switch, but there's a much more insidious or dangerous problem lurking beneath the surface here. So let's imagine we're looking at this function, we're calling it, we're going to call the function, and we're just going to calculate the age using plain SQL directly. And we'll do that for person, and we run it, and we get a result that looks like this. So function gives us 39, and the calculation gives us 29. It's like, hang on, what the heck happened there? Or how did we end up with different results for these functions here? Okay, well, this relates to the read consistency model for Oracle database. So typically, by default, when you run a query, results are fixed at the time the query starts. However, calling a function within your SQL changes that slightly. So let's imagine we've got 2 sessions here. The first of those, we're calling our SQL statement with the function getAge. And this runs for a while, gets the rows out of the table, and eventually gets around to actually calling the function. So calls the function, runs it, runs the SQL statement, and then passes the result back, which goes on, returns to the client or whatever it is. While this is happening, we're doing this, someone else has realized there's an error. There's a mistake in the age for this person. And so what they do is they change that person's birth date and commit it. All this happens while this first SQL statement is running. So it's between the start of us hitting go and it actually getting around to calling the PL SQL function. We now are in a new read consistent view of the database within our function here. So what happens is when this runs, it's viewing the result of what's happened in session 2. So we've now offset our timings here. Instead of having all the queries start exactly the same time, which is what would have happened if it was just pure SQL, everything directly in the one statement, we've now broken that rule. So we've separated things out here. And this is one of these things that can lead to weird, one-off errors. People run a report and kind of go, well, hang on, halfway through the results changes and we can't figure out why. We run it again and everything's fine and no one can figure out what's going on. Particularly if this is things like reference data, which relatively rarely changes. So people are going to scratch their heads. You end up wasting a few days trying to figure out what the heck the problem was, forget about it until a couple of months later when the problem comes around again. So this is something you really need to watch for. And, we've got to think about the performance overhead, but more importantly, we've got this consistency issue. We can get incorrect results or unexpected results, which is a harder problem to work around. Now, you can do things like set the flashback time, the start time for the query within the function to the same, but that's getting messy. So, Stephen, anything else you want to add on that?
Yes, I made myself visible just to emphasize how important it is, I think, to really keep this in mind. And I think the problem here is that Oracle database makes it so easy for us, the whole read consistency model, the idea that you start a query, however long it runs, don't worry about any of the changes out there, we've got your back. But this is a situation where you can definitely break that model by calling these functions that have selects in them. So just take it really seriously. Okay, that's it.
Thanks, Stephen. Yeah, I know some people are kind of a bit like, yeah, you don't need to worry about this. This is kind of, it happens rarely. But I think the fact that it happens rarely is one of the reasons why you need to try and avoid this, because it ends up being one of those problems that you lose, hours, days of support time trying to figure out what the heck happened, chalk it up to one of those things, and then months or years later it happens again. So
exactly,
it's people kind of go, oh, it doesn't happen very often, you don't really need to worry about it. I think that's the wrong attitude. In some ways, it's things that happen rarely that catch you out more because you forget exactly how you fixed it last time or what the issue was.
Right. And it could be that either you can identify that it's not an issue, that you really don't have to worry about it in this case. It could also be that, yeah, maybe we'll get some minor differences in the data, but in this case, it doesn't matter because we're looking more for aggregates. And if we're off by 1 or 2, eventual consistency in this case might be okay inside an Oracle database. Wow, did I say that? But it's something that should be the result of a very careful analysis. And Judith has written a little suggestion. A good enhancement request would be to have a built-in function that when called from a SQL statement, returns the read-consistent SCN of that statement. Then it could be passed as a parameter to any function called from that SQL and used for performing a flashback query with that SCN. Interesting idea. Feel free to log it as a request idea. I think there's a lot we could probably do to make it easier for developers to work with SCNs. I've got to think that very few of us around the entire world, including moi, have actually built in usage of SCNs and watching for SCNs as part of our transactions. And I know I'm a bad person, a worse person for it, but it is quite complicated. So it would be nice to see some features that help us do that.
Yeah, I agree. I think something that made it a bit more transparent, like a SCN consistent keyword or something like that, just so you didn't have to think about it quite so much, because I've never seen anyone, or at least not in the real applications, do the SCN flashback query within a function to avoid this problem. So yes, great idea, Judith. Okay then, so just kind of wrap up on these things. So there's a few things we've talked about and some things that you should avoid doing when calling functions in SQL. So as we just talked about quite a bit, if you've got SQL, going to PL SQL, back to SQL again, just avoid it, right? You've got the double hit of the context switches going between the two engines, but more importantly, it can lead to these weird, hard to track down errors with data consistency issues. So just avoid it and come up with a different approach. Another thing, as we saw, if your function is non-deterministic, do not use the deterministic keyword. Hopefully, doesn't need saying, but again, some people going to go, well, if we want these virtual columns, we have to declare the function as deterministic. So we'll just do that temporarily as a workaround so we can kind of get it in and then worry about the problems later. You're almost always going to store up some bad issue for you later, so just avoid that. And come back to the point Judith made about functions in where clause. So far we've been looking at them in your select statement. So this means that the functions are only called from the rows that pass your where clause. So we've got our people with 1 million rows. If we only look up one row and we call a function for that, we're only calling it for one row. If, on the other hand, I've got in my where clause where formatted name equals Saxon, Chris, or whatever it is, then I'm going to have to call that function for every single row in the table. So a couple of issues here. We have to full scan the table, and we're doing the performance, the context switch for every single one. So this is kind of bad. Now, you can get around this by creating a function-based index. And in some situations, that might be the right thing to do. But again, generally, I just say avoid it if at all possible, because you're making that less reusable. It's better to move the logic from the columns to the other side. So rather than saying, here's my formatted name, here's my function format and name, check that the matches the formatted name value, use the given name, family name, and check those equal the individual values. So move the processing off the columns to the other side of the where clause, other side of your criteria, if at all possible. So just avoid those. Yes, another way is to use operators which are read from Judith. Yeah, could you? Yeah, I'm not sure what you mean by operators either, Judith. So if you could give us, I mean, it's using the create operator statement. Okay, it's not something I've ever used.
Me either.
Yeah. If you've got a bit more background on that, please share. Maybe we can look at that at a future session. But
yeah, Judith, you might submit it as a question on the PL SQL Office Hours page, or perhaps more for SQL, and then we can be prepared to take a look at it next session.
Yeah. Okay, so those are the things to avoid. However, there are some things which I think you should do. So now, one of the things we've seen is looking at using scalar subqueries. These can give quite a big performance benefit. Now, they can be a bit fiddly. In particular, if you've got a lot of SQL statements and they've got a lot of functions in them, does that mean, am I saying you should go through every single one of them and create a scalar subquery? No, right? I'd reserve this for kind of like big report jobs, batch jobs, where you're processing lots and lots of rows and having to call the function for every single one of them. So do look at those. They can give some good performance benefits. Moving on, I hope I haven't scared you off with the deterministic keyword. If you know the function is deterministic, then you should use a deterministic keyword. As we saw, that did actually give quite a good performance benefit. And as Stephen's said, we're giving more information to the database. So hopefully you can get a bit more detail and future optimizations. As we find better ways of dealing with these things, we just tell the database what you're trying to do. There is no easy way for us to figure out that a function is truly deterministic. You've got to tell us. Another thing, just make sure you test, right? Hopefully, I've shown that even on one table, just slightly different functions can give quite different performance characteristics for each of these different options. Make sure you test on your data and validate that it really gives the performance benefits that you want. Don't just kind of rush in and go, okay, we've got to stick everything in a scalar subquery, stick the deterministic keyword, and maybe do pragma, UDF, or whatever. Validate, check. You're not always going to get huge performance gains from all of these things, and in some situations, some may perform a lot better than the others. Related to that as well, so far, I've been doing everything in a single user environment. I've run one query, just me, no one else using the database. Think about what happens if lots of people are going to be calling these at the same time, which is much more likely in a real-world application. So this is an area where the function result cache can really start to benefit you. So quite often, your query might only return a few rows. So you're looking up a handful of orders or a few lines at a time for a particular customer. And so you're only calling that function 3 or 4 times. So performance benefits you get from scalar subqueries probably going to be kind of minimal. However, different people might be calling that same function with the same inputs. If lots of people are ordering the same products, you've got a really popular thing, they're all going to pass the same values in. The savings there could be a lot bigger when you're in a multi-user environment. Scalar subqueries, deterministic, the optimizations there only apply within your query. As soon as your query is finished, any benefits that you got from those are kind of disappeared and gone. Whereas with function result cache, as long as you're passing the same values in, we can avoid having to execute that function. So that's an area that can be really benefit. So do realistic testing. Think about how your application is going to be used and test under those circumstances. Okay, so anything you want to add on that, Stephen? Any other questions that we've got?
No, I think you covered it very nicely. We have no other questions. The create operator had to do with the Oracle Data Cartridge functionality. And so we can take a look at that. It's probably about on the order of complexity and usage as using SCNs in your transactions. But I love that Judith knew about it, and we'll take a look. And here's a question from Joseph. Would using deterministic with a result cache function provide any benefits beyond using result cache on its own? Excellent, fun question.
Yes. Yeah, so something I haven't mentioned, you can actually combine all these options, right? You can put them all in the same, you could do a scalar subquery with pragma UDF, deterministic, and function result cache. You can combine them any which way you want to. The performance benefits you're going to get is going to depend a lot on what you're trying to do. But, again, if you need to think about what you're trying to achieve. If you really need to juice every last second out of a SQL statement and you need to use those functions, it's worth trying them out in various combinations to see what helps. But
I think that there's certainly no problem with combining them. Sometimes you can combine different features like save exceptions with for all and the log errors functionality is not, you can't combine them. In this case, you can, and part of the reason you can and should be able to is that they're very different in what they're doing with your code. So again, deterministic keyword, put it on your function if you know it's deterministic. At a minimum, you're simply self-documenting to future developers not to make it non-deterministic because it's intended to be used in a certain way. So I think deterministic is almost always a matter of documentation. And then if the SQL engine can take advantage, great. And then what you're really looking at is a cascading effect of do caching wherever you can, right? Do caching in the back end, do caching in the middle tier, do caching in the front end. So in the back end, the deterministic caching should happen sooner than the result cache would take place. That's how I would understand it. That if the SQL engine can determine that it doesn't need to call the function again because you're passing in the same parameter values within that single select statement scope, it's never even going to get to the point where the result cache mechanism comes into play to determine whether or not it's in that cache. So for sure, there's no reason not to combine them. I think deterministic is always safe to add if it's really deterministic. Result cache is something you want to use with a lot of care. You want to work closely with your database administrator until you get to autonomous to basically say, look, we want to do result cache. Is the pool going to be big enough? You know, help us out to determine whether or not it's a good performance and data usage profile. That's all I got.
I think that's good. Yeah. Okay. Okay. So there's likely no harm in using every feature that applies. Understood. Thanks. Yeah. Like I say, certainly, as Stephen said, just if it's deterministic, add deterministic. Result cache, you'll want to check a bit more and test a bit more thoroughly. Again, pragma UDF again. It may give good benefits. It may not. So.
But it looks like we haven't seen any noticeable downside on UDF. It may not give you benefits that you were hoping for, but I don't think there's any indication that it will. There's any real negative aspect to putting it on if you know you're going to use it mostly in SQL and the potential benefit down the line is higher. Yeah. I think that would be that's a pretty accurate.
Yeah, you may end up with no real benefits at all, but yeah, I think it's like Stephen says, you know better what the purpose of your function is, and doesn't matter how good our autonomous stuff gets, you will always know why you wrote the function, and we never will. So the more information you can give us, the database, the more optimizations we can do, the more we can find clever ways that you don't even have to think about to improve the performance. So that's your skill as a developer, your task to kind of help, give us the information the database needs.
Yes, help us help you.
Yes. Okay, so there was a question that came in advance about pipeline table functions and using those in parallel. Doesn't look like Sven, who asked that's on the call, and it's quite an involved thing as well. So I think I'll put that off to next time. We'll look at pipeline table functions, how they work, calling those in parallel, and so on. So
we do have another comment from Eric Van Roon. You haven't gone into PL SQL in the with clause yet, but deterministic then is ignored in 12.1 and 19. In 12.2 and 18, sometimes deterministic behavior is observed, and I found at least one case where it produces wrong results.
Okay, Eric. So if you could share us some examples of that, if you could post on Ask Tom or just email us, that would be useful for us to see exactly what's going on there. But
that'd be great. So I think what you're probably saying, and in fact, Eric, if you want to unmute and talk, we will allow you. It sounds like you're saying the definition of the function inside the with clause, and you're adding deterministic on that function inside the with clause. And I could definitely see that maybe the way they implemented the with clause would interfere with that or disable it, though it looks like we got some inconsistency going on. In terms of your one case where it produces wrong results, that's a bug, I would say, because we're not supposed to produce wrong results, or at least we weren't aware of an interaction. So if you could, for example, document that on live SQL in a script, we can then take that and run with it.
Yeah.
Thanks, Eric.
Can you hear?
Yeah, we can hear you, Eric.
Well, documenting it on live SQL isn't going to work because, as I said in the comment, in 19 deterministic in the with clause is ignored again, like it was in 12.1. Maybe because of this bug, I don't know. But so documenting it on live SQL won't work because the wrong results won't show there.
Gotcha.
I will send you an email about my results, so you can have a look at that. Okay?
Okay, and we'll check with the developers. It sounds like if you're right about 12.1 and 19 bracketing the correct behavior, which was ignoring it, and then sometimes using it in between, it could be that it was a regression that they fixed, and we'll see if we can find out about that. Thank you, Eric.
Okay.
Yep.
And there's a question from Frank. Can you explain sysref cursors and DBMS SQL return result?
So you saying? Oh yeah, I'm not sure exactly what you're asking there, Frank.
Are you looking for a general presentation on ref cursors, Frank? Because we probably can't get into too much detail at this point, but we can certainly cover it in a future session. And we can take a look at how DBMS SQL uses ref cursors. I think it was introduced in 12.1 to essentially emulate SQL Server-like behavior in which you can have a procedure that basically runs a select statement and automatically displays the results to the screen, which is something PL SQL hasn't supported, but we implemented it through this pathway. As far as I know, it was essentially implemented for SQL Server T-SQL emulation.
Yeah, okay.
I understand this. Yeah, so let's take that as an advisory to take a look at sysref cursors in a future session.
Yeah.
All right.
All right. Any last comments before we wrap up? We're approaching the hour.
Looks good.
No. Okay then. So in that case, just want to thank you all for joining us. Thank you, Stephen, for your comments and helping.
Thank you, Chris, for doing all the heavy lifting in this session. Much appreciated.
Yep.
All right. Hopefully we'll see you all next month.
Yep. And let's say next time we'll cover pipeline table functions, look all at those and see if you've got any questions, add them on the office hours questions page and we'll pick them up and introduce those. So thanks again.
Happy coding, everybody.
Yeah.
Bye.
Enjoy. Bye.